Hi everyone, so today we're going to be talking about how to write linear equations. This is part 4 of writing linear equations. In this case, we're going to talk about how to write linear equations when you're given a point and then a slope either parallel or perpendicular to the line that you want to write. So we're going to be using the same general equations that we've been using, which is the point slope form, which is y minus y1 equals m times x minus x1. The other things that I want you to know before we get started with the examples is that if I say that it's parallel to some line, that means that it has the same slope. And if I say that it's perpendicular, that is negative reciprocal slopes. Oh, sorry. So negative reciprocals are basically if I take a fraction, I flip it over so that the top becomes the bottom and the bottom becomes the top, and I make it negative, or I flip-flop the signs. So let's just go over some examples. The first example is we want it to go through the point 2, 3 and be parallel to the line y equals 4x. So the first thing that we're going to do is figure out what the slope of the line parallel to it is. And the slope is the number in front of the x. And so in this case, that's 4. So I know that my slope is 4. Because we want the line to be parallel, we want it to have the same slope, which means that the slope I'm going to be using in my equation is also 4. Now what I'm going to do is use these two numbers as my x1 and my y1 and just plug them into that point slope form, which is up here. So we've got y minus y1. Sorry, my pen's being a little bit funny. Let's see if I can make it work. There we go. y1 equals m times x minus x1. I'm going to say y minus my y1, which is 3 in this case, equals m, which we decided was 4, times x minus x1, which is 2. All right. So now what we're going to do is distribute the slope. So we get y minus 3 equals 4x minus 8. Then I'm going to solve that for y to get it into point slope form. And the way I do that is get rid of the 3 by adding it to each side. So I get y equals 4x minus 5. That's my slope-intercept form. Now what we want to do is find the standard form of that. Standard form, if you remember, has the x and y on the same side. So I'm going to subtract 4x from each side. So I get negative 4x, and I've always put the x first, just because that's the way that standard form goes, is ax plus by equals c. Then there's 2 rules to standard form. The first rule is that you can't have fractions. Well, we don't have fractions in this case, so that's great. The second rule is that you can't start with a negative number. We are starting with a negative number, so to get rid of that negative number, all I'm going to do is multiply everything by negative 1. If I multiply everything by negative 1, all that does is flip-flop all of the signs, so the negative 4x becomes positive, the positive y becomes negative, and then the negative 5 becomes positive, and that is our standard form. All right, let's do another example. So in this example, we want to go through the point negative 5, 1, and we want it to be parallel, so same slope again, to x equals 1. Now this is a little bit odd. If we're trying to find the slope, because that's the goal always, is to find the slope of the line that they give you first. This one has an undefined slope. When I graph x equals 1, it looks kind of like this. So that slope is considered undefined. When you get something like this, what's going to happen is if we want it to be parallel, that means that if we want to draw a line that's parallel, we need another vertical line. And to make another vertical line, we need it to be just another x equals equation. In this case, because we want it to go through this negative 5, 1, we're going to have it be x equals -5. Because if I were to graph that, I'd be 1, 2, 3, 4, 5, and it would look like this, which is parallel to that x equals 1 line because they have the exact same slope. They look like the exact same thing. It's just kind of shoved over a little bit. And so this is actually my answer, and that's my answer for both standard form and slope-intercept form because there's no way that you can get that into either form. Okay, now that was a little bit of a weird one, but let's go through now some perpendicular examples. So the next example, we want to go through -1, 8, but this time we want it to be perpendicular to y equals -3x minus 5. Okay, so the first thing we're going to do is find the slope of this equation, which is the number in front of the x, which is that -3. So I know for this equation that m is equal to -3. But here's the deal. Because we want it to be perpendicular, what we're going to do is flip that into a fraction and switch the sign. So -3 is the same thing as me saying like -3/1. So if I were going to flip that, it would be 1/3, and in fact it's like a -1/3 because that 3 stays negative, but because it's a negative reciprocal, we can take that negative away because we're going to flip-flop the sign. So my new slope, or the slope that I want to use in my equation, is just 1/3. And then once again, this is your x1, this is your y1, and we're going to use that point slope form. So we've got y minus y1 equals m times x minus x1, and we're going to replace the y1 with 8, the m with our new slope, which is that 1/3, and then the x1 with -1. Okay, so now we're just going to simplify a little bit. When I have two negatives right next to each other, like right here, I can actually make this a big positive because a negative times a negative is a positive. Then what we're going to do is distribute the 1/3, and we'd get y minus 8 equals 1/3 times x is 1/3 x, and then 1/3 times 1 is 1/3. Then we want to get it solve for y. So to get it solved for y, we would add the 8 to each side to get rid of the 8. The 8's cancel out on the left side, and we're just left with y equals 1/3 x. And then 8 plus 1/3 is 8 1/3, or we could say it's 25/3. That's just the improper fraction version of it. So this is your slope-intercept form. Now we want to get it into standard form. So what I'm going to do, so we want to get the x and the y on the same side, and usually that's my first step. But sometimes it's easier, especially when you have fractions, to get rid of the fractions first. So I'm going to get rid of the fractions first. And the way I'm going to do that is by multiplying each chunk by the denominator. So I'm going to multiply everything by 3. And if I were to plug that into a calculator, I'd get 3y equals, and then 1/3 times 3 is just 1. So I'd get 1x plus 25/3 times 3. The denominator and the 3 cancel out, so I just get 25. Okay, now let's move the x over to the other side by subtracting it because we want the x and the y on the same side. So now I get -1x plus 3y equals 25. And same rules apply as last time. We don't want negatives in the front, so we're going to multiply everything by -1. And we would get 1x minus 3y equals -25. And that is your standard form. Okay, let's go through one more example. In this example, we're going to go through the point 4, -9, and we want it to be perpendicular to y equals -5/6 x plus 4. So once again, find our slope. Oh, that's -5/6 because that's the number in front of the x. So we got m equals -5/6. But because it's perpendicular, we want to do that negative reciprocal thing. So we're going to take that fraction, flip it around, and switch the sign. So I'm going to get m equals, flip it around. Because I'm going to switch the sign, I'm not going to put a negative there. It's going to turn positive. So this is my new slope, this 6/5. And then once again, this is your x1, and this is your y1. Okay, so now we're going to use y minus y1 equals m times x minus x1. plug in everything that we know. So it's going to be y minus negative 9 equals my new m, which is 6 over 5, x minus 4. Okay, now those two negatives right here can make a big positive, so it's y plus 9. We're going to distribute the 6 over 5. So we get y plus 9 equals 6 over 5 times x is 6 over 5x. 6 over 5 times 4 gives me negative 24 over 5. Then, still want to get y by itself, so I'm going to subtract 9 from each side. So we get y equals 6 over 5x, and then negative 24 over 5 minus 9 would be negative 69 over 5. You can definitely use your calculator in that situation. And that is your slope-intercept form. Now the very last thing we have to do is get it into standard form. I'm going to do it the same way as we did it last time by getting rid of the fractions first. To get rid of the fractions, I'm going to multiply every single chunk by 5 because that's the denominator. And when I multiply by 5, those denominators on the fraction should go away. So I'm going to get 5y equals 6x minus 69. And then I want to get the x and the y on the same side. So I'm going to subtract 6x from each side. So I get negative 6x plus 5y equals negative 69. I don't like that there's a negative in the front, so I'm going to multiply everything by negative 1, which just flip-flops all the signs. So I get positive 6x minus 5y equals positive 69. And this is my final answer. There we have it. Writing linear equations, part